All right, we've almost made it to the end of Chapter 4. Chapter 4 is kind of a beast. It's kind of the beast of first semester. It's a long, meaty chapter. There's a lot going on in this chapter. We've finally made it to the end. Here's another kind of crazy redox reaction. These last two are a little unusual, but it's kind of nice to throw them at you just in case you would ever see anything similar. We've got kind of a skeletal equation, net ionic. They're indicating that this reaction takes place in a basic solution. So I want to split this into the two half reactions, which means I'm going to go through and put in the oxidation numbers right away. Solid chromium is a 0, that's its elemental form. I've got the chromate ion, CrO4 minus 2 or 2 minus. We're going to start with the oxygen because we know it's always a minus 2. That gives me a negative 8 because there are 4 oxygen. So I just pick the charge on chromium. That'll leave this particle with an overall charge of minus 2. Chromium's a plus 6. On the product side, I've got some chromium hydroxide solid. I know that oxygen and hydrogen are always gimmies. Negative 2 on the oxygen. That's a plus. Plus 1 on the hydrogen. So hydroxide has an overall charge of minus 1. There are 3 of them. And this particle is neutral. So the chromium must be a plus 3. All right. So we want to find whoever is changing oxidation numbers. And then we'll split these into the two halvesies. Oxidation involves losing electrons. If you lose electrons, you are becoming more positive. Okay, I see something that jumps out at me. How about this chromium solid going from an oxidation number of 0 to an oxidation number of plus 3 in the chromium hydroxide. So here's 1 half. This is the oxidation half. I'll have the chromium turning into chromium hydroxide. Now I want to get the other half, the reduction half. There we go. Reduction involves gaining electrons. If you gain electrons, you become more negative or less positive. Oh, well, this is goofy. Oxygen stays the same on both sides. What about this other chromium? The chromium in the chromate ion is reduced. It goes from a plus 6 to a plus 3. This is unusual. The product is the same. Minus 2 or 2 minus going to the chromium hydroxide. Weird. I have a feeling that when we get this thing all balanced, we're going to have a 2 as the coefficient in front of that chromium hydroxide. This is okay. It's okay to have the same element both oxidized and reduced. You may run into a question like that. It's kind of a trick question. They might ask you, like, what element is oxidized? What element is reduced? And you'll be like, oh, I don't know. Can it be the same one? Sure it can. Okay, so let's balance these two individually. The first one, I've got 1 chromium on each side, so we can attack the oxygen by adding water. We need 3 of them on the reactant side. Then I balance the hydrogen by adding hydrogen ions. So this starts out just like an acidic redox. I have 6 hydrogen on the reactant side and 3 on the product. So we'll take 3 more hydrogen ions. And then before we get too excited, we need to balance the charge by adding electrons. The reactant side is neutral. So let's add 3 electrons and make the product side neutral. All right, I like it. Done. The reduction half, there's 1 chromium on each side. So we'll go to water to balance the oxygen, we'll need 1 on the product side. So I've got 4 oxygen on both sides. Now I need to balance the hydrogen by adding hydrogen ions. There are 5 on the product side. So we'll put 5 on the reactant side. And then finally I need to balance the charge by adding electrons. My product side is neutral. My reactant side is a +3. So we'll add 3 electrons. This looks good. Oxidation involves losing electrons, so my oxidation half produces 3 electrons. Reduction involves gaining electrons. My reduction half gains 3. Perfect! That's usually one of the big mistakes people will make, is that they get to this point, they're all excited, let's add it up and be done. And they'll forget to check that the electron transfer is the same on both half reactions. In this case, we get lucky. It is the same, 3 electrons for both, which means we can add these up right away. We're going to cancel like terms, so we should definitely cancel these 3 electrons. You guys are out. And then I look for anything else, like hydrogen ions, water molecules. There's both. Let's narrow down the water. There's 1 produced. Let's bring this down to a 2. Hydrogen. We could get rid of these 3 on the product side. And we could narrow this down to 2. All right, I like it. So let's see what this thing looks like. So far, in any order, we would have the 2 waters, the chromium. In the second half reaction, I have 2 hydrogen ions and the chromate ion. The electrons are out. That's as much as I can do on the reactant side. The product side, we can write this as 2 chromium hydroxides. Hydrogen's gone, electron's gone, ooh, water's gone. Crazy, but it's right. If this were an acidic redox, we would be done. If it's a basic, you have 1 more step. You get down to the end, and now we look for any existing hydrogen ions. There are 2 of them. If this isn't a basic solution, there would be hydroxide. Hydroxide loves hydrogen. So we're going to add the same amount of hydroxide to match the hydrogen, and we have to add it to both sides of the equation. +2 hydroxides. And again, what this will do is add water. The hydrogen and hydroxide are going to combine to form 2 more water molecules. So sometimes I need to kind of check and see if I can simplify this. If there would have been water on the product side, I might want to simplify it. Or in this case, I can write this now as 4 water molecules. I originally had 2, and now I'm going to add 2 more. So in a second, there we go. We'll say 4 waters, the chromium, the chromate ion. On the product side, we're going to have the 2 chromium hydroxide and 2 hydroxide ions. Another real common mistake with these basic redox is that they get to the end and people will forget to add the hydroxide on both sides. But you'll catch that if you double check now and make sure that everything's balanced. So I have 8 hydrogen on the reactant side. I have 6, 7, 8 hydrogen on the product side. I have 4 and 4, 8 oxygen on the reactant side. I have 6 and 2 for 8 oxygen on the product side. 2 chromium, 2 chromium. Atoms are balanced. The charge balances as well. -2 on both sides. It's done. Everything balances.